Hello! If you're in the business of capturing, processing, or analyzing drone data, you might have come across the saying that it's not about the drone, it's about the data. And if it's actually about the data, then how do we make that drone data more and more useful in the architecture and in construction space? We'll have a look in this video. Hey everyone, I'm Varun from Hammer Missions, and if you watched our channel, you know that we cover lots and lots of videos on drone data and AI. And in this particular video, we want to talk about how do you take drone data and make it more useful for architects, engineers, and contractors. Let's have a look. So when it comes to drone data, one of the things we have to really internalize is that the drone data that's being captured is being captured for a particular reason. And that reason is to essentially try and answer some particular decision, some particular insight using the drone data as an input. And sometimes that data needs to be transformed by architects, engineers, and contractors into a format that essentially allows them to use it in their tools of software and in their ecosystem for a diverse range of purposes. So what we're going to cover in this video is essentially how do you take drone data and convert it into things like CAD and BIM, and essentially try and understand that process from start to finish so that that data can be made more and more useful. So let's get started. Step number one is to essentially think about capturing the data in the right way. And by what I mean by that is essentially thinking about, well, what is the end output we're looking for? Are we looking for something like a CAD file? Or are we looking for an elevation drawing? Or are we looking for a BIM model at the end of this process? And knowing that essentially allows us to capture the data in the right way. For example, if you're looking to produce a CAD file, which is typically 2D, you would be capturing with that particular notion in mind, and therefore your flight plans and the data capture will be very much focused on 2D as opposed to 3D. Having the 3D is nice, don't get me wrong, 3D is almost always more information, but if your end goal is actually to produce a 2D CAD drawing, then you need to think about, well, what is the right way to capture this 2D data? And so whether you're doing a roof drawing or whether you're doing an elevation drawing, you need to think about, are we capturing in the right way with the right flight plans to be able to produce that 2D elevation drawing or CAD drawing? Same goes for 3D. If you are producing a BIM model, building information modeling, for those of you that have just come across this term, if you're trying to produce a BIM model, we know that we're capturing in 3D, and therefore whatever we're going to be capturing has to produce a 3D model at the end of this. And so again, thinking about the flight plans, thinking about how we're going to be able to capture both the roof, the facades, the entire building envelope, or if you're trying to capture some other structure such as a tower or some other thing, you need to make sure you've got all of that rich 3D information being captured, and therefore back calculate what is the right flight plan. Incidentally, we made a whole video on what are the best flight plans to be able to create 2D maps and 3D models. And so if you're curious about flight plans, you should go watch that video next. So once we've got a step one nailed, which is to capture the data in the right way, the next thing we have to think about is, well, once we've got this data, what do we do with it? Well, just like you've got raw information that gets processed into meaningful insights, we need to take this raw information, which is the images with high levels of overlap between them, and we need to process them into 2D maps and 3D models. And so depending on whether you're producing a CAD file or you're trying to produce a BIM model, you take all that data and then you process it. And you may choose to process it in 2D or 3D or maybe both. And so knowing whether you're going to be processing the data in one way or the other and what kind of output formats you're going to see at the end of it is really important. So step number two, process the data in the right way. Step number three is to actually download the data. Now, to process the data, you might have used a software platform that provides photogrammetry and allows you to process all this data. We at Hammer Missions provide a software platform for you to be able to do that. So you can essentially upload your data, process the data, and then download in 2D or 3D formats. But step three is to essentially download the data or export the data in the right format. And so with the 2D side of things, the format you're looking for is essentially a .tiff file. And so this could be a GeoTIFF file, which is a geo-referenced TIFF image. And essentially this file can be imported into things like AutoCAD directly. And so bear in mind, you've got to get the right formats, and formats is really important when it comes to the AEC space, because every software that is used essentially has an input and output format. So getting the 2D file, elevation drawing or roof drawing in the right format allows you to then use it in AutoCAD for the 2D side of things. For the 3D side of things, you again need to download the data, but you need to download the data now in a .las format. And so the .las format actually comes from the laser scanning world, but it's a very commonly used 3D point cloud format that can be used to essentially export the data. If you're confused about all these different formats, I've actually made a whole video on drone data formats, so I would recommend watching that video next. So for 3D, for BIM, you download the data into .las formats, and once you've got that .las file, you're not quite done actually. You need to take that data and then make it available in things like Autodesk Revit. So Revit is a 3D BIM tool that's widely used in the architecture, engineering, and construction world, and it accepts essentially a .rcp file as an input, and it can actually interpret that sort of 3D data. But then the question is, how do you get that .rcp file? And this is where you need another software program. I'm sorry for all the software programs you need over here, but that's just the way of the world. You've got inputs and outputs, different formats, and they need to be able to talk to each other. So you need another software program called Recap, and that Recap is going to be able to take your .las file as inputs and output essentially a .rcp file that you can then import into BIM tools such as Autodesk Revit, or even things like Civil 3D. And so you're able to actually get your point cloud data from the drone world into the Recap world, and finally into the Autodesk Revit and Civil 3D ecosystem. So that's how you're able to get that data flowing. And once you've got that data imported, so now you've got sort of step 4, which is to import the data. In step 4, if you're looking at the AutoCAD side of things, which is also an Autodesk product, on the AutoCAD side of things, what you've got to do is you've got to take the TIFF file and you've got to import it as an attachment. And we're going to show you that whole process in a future video, but basically you've got to attach that TIFF file as an attachment, and you're able to actually then use that in AutoCAD environments. Equally, if you wanted a CAD file, you can also export the CAD file in DXF format, and with GeoCoordinates, you're also able to import that into AutoCAD. So again, all of this is 2D, so it is very much for roof drawings, for land surveys, for elevation drawings, everything that you need with essentially just 2D information. It could be a topographic survey, it could be a roof survey, it could be an elevation survey. So that's how you're able to get the data imported into AutoCAD. At the same time, for 3D, you've got to follow a slightly more sort of complex process in some sense, where you've got the recap in middle. In recap, you're able to import your laser scans or your laser data, and that's where your .las file is imported. And once you've imported that, you're able to actually export the RCP file, which then goes into BIM tools like Revit and Civil 3D. So that's how you're able to import the data. And then the final step here, which is step 5, is to actually be able to work with the data. And so with an elevation drawing or a roof drawing or a 2D side of things, you're basically able to actually use that data to trace a new drawing. You might be able to create a new drawing by using the drone data as a background layer. Or maybe the data is rich enough that you can actually use it for all of your work. And when it comes to, for example, facade surveys, you might be able to get a facade orthomosaic out from your software. For example, at Hammer Missions, we're able to export an orthomosaic for facades. And once you've got that facade image, you can import that and then essentially use that for your markup. And so you can use that in Autodesk, you can use that in AutoCAD to be able to create your line work or to be able to do your markup. Anything that you require is now possible. And because the data is scaled, you can even use it for measurements, and you can use it for all sorts of different purposes. So you've got that as your core workflow in terms of what you do once the data has been imported. And then on the 3D side of things, you've got a very similar story. You import the data into Civil 3D, or you get it into Revit, and now you can essentially use it for all sorts of different purposes. You can do your measuring tools, or you can use that to essentially draw over, or to essentially cut and fill, or to be able to actually look at the data, slice and dice the data in different ways to look at the cross section. It's the world your oyster when you've got all that sort of nice 3D laser point cloud data that has been imported into a BIM tool like Revit or Civil 3D. So hey, that's it guys. You've got a 5-step process on how you can get drone data captured, processed, exported, and then imported into tools like Autodesk, Revit, and AutoCADs. Hopefully this video was interesting. We're going to show you the entire workflow on desktop, and if you want to know how that works, hit that subscribe button so that you get notified when we make that entire video, and we'd love to see your comments on that. Thanks so much for watching. We'll see you in the next video at Hammer Missions.